recording? All right, okay. So again, since we were discussing functions, let's talk about some more questions from this chapter. The first part is easy, but the second part is related to the first part. That's why I'll be talking about the first part as well. Now, according to the question, it says the functions f and g are defined by. Now we have two functions f and g. F of x is x squared minus 4x plus 3. And when it comes to the domain, it says that x is greater than c. Now c is a number, we're not sure about c. C is a number and x is greater than c, okay? And then we have another function. We won't be talking about this function in the first two parts, just forget it, okay? So we have one function f of x, and f of x is x squared minus 4x plus 3. So basically it is a quadratic function. And here is the domain. We'll be using that later on. For now, let's just focus on the first part. Express f of x in the form x minus a whole squared plus b. Now we have been doing a lot of questions, and by now we should know whenever you see something of this type, only completing square method should come to your mind. Okay, this is nothing but the completing square method. So what exactly is the completing square method? It's very easy. We need to make sure that the coefficient of x squared is 1. For now, it's 1. So we won't be taking anything common. We can directly write it down. F of x is x squared minus 4x plus 3. We don't need to take anything common. So I can write it as x squared minus 4x. I need to add and subtract square of a number, and that number is half of the coefficient of x. So the coefficient of x is 4. What is half of 4? It's 2. So I'll be adding 2 square, I'll be subtracting 2 square, and then I'll be writing down plus 4 as it is. Okay, so I'm pretty sure by now you guys would be knowing why we are adding and subtracting, because this is maths. We need to balance things. Okay. Yes, any questions? Mudassam? Okay, Mudassam, your mic is unmuted.
Oh, sorry.
Okay, all right. So after this, we need to write it down this way. It's going to be x minus 2 whole square. Then we have minus 4 plus 3. And then this would become x minus 2 whole squared minus 1. Okay, so this was basically the question. We have converted f of x to this form. All right, so once we are done with this, the next part of the question is basically what we need to focus on. Okay. All right, so this was easy, and now it's very clear that a has turned out to be 2 and b is minus 1, right? These were the two constants, and we have calculated them by converting it to the other form. Okay, let's focus on the second part of the question, then it would make more sense. The second part says, it is given that f is a one-to-one function. Okay, f is a one-to-one function. So at times the examiner writes it is given that the inverse of the function exists, or he is going to write f is a one-to-one function. Now, this is important. I would want all of you to please pay attention on this this part. This is very, very important. Okay, the examiner is giving you some information. He's saying f is a one-to-one function. Apparently, when we look at f, I'll scroll up, and f is a quadratic function. And if I make the graph of this thing, you guys clearly know that according to the horizontal line test, this entire graph would not be a one-to-one function. We need to restrict the domain, and then it would become a one-to-one function. Okay, let's just make the graph of this, and then we will get into this discussion. Forget about the question part now. Let's just focus on this. We got f of x as x minus 1, x minus 2, obviously. X minus 2 whole squared minus 1. Again, students, please pay attention. It's extremely important, okay? This is the function f that we got after completing square in the previous part. And for now, forget about the question. I would want to make the graph first, and then we'll talk about the question. So Let's make the graph on one side of the page. This is the x-axis. This is the, sorry, that was the y-axis. This is the x-axis. Now, this is my quadratic function that I need to plot. Okay, so first of all, I need to see, yes, when I will expand, or initially we had the function in the expanded version, we can clearly see that the coefficient of x squared is +1. When the coefficient of x squared is positive, we know that we would be having a U-shaped curve, right? So it would be a U-shaped curve. And can anyone tell me the coordinates of this minimum point? Yes, please think about it. They are right in front of you.
2 minus 1.
Very well done. Excellent. Very good. Both of you. This is 2. And let's say this is 2. And this point is -1. So I can just write down the I can make the minimum point here. Okay, now just make a rough graph according to your convenience. This would be a minimum point. Forget about the y-intercept or the exact x-intercepts until and unless the examiner has asked you to, sketch the graph. We are just making this graph for our understanding. Otherwise, the graph is not required. So it's completely fine. We just need a rough shape. And here's the rough shape. Okay, now this is the rough sketch of this graph. This is going to have a minimum point and the coordinates of the vertex would be 2 and -1 and so on. Okay, let's see what exactly was the question about and why did we even plot this? Why did we even need this? Okay, so here is the question. It is given that f is a one-to-one function. Now, one-to-one means for one x, we should only have one y. But if we look at the graph for now, if I make one horizontal line, this is my horizontal line, I can clearly see that I have two x values that are corresponding to one y value. Again, if I make the graph, I would be having two x values which are corresponding to one y value. Okay, this was the initial y value. This is again another y value. Again, if I make a horizontal line, again 2x values that are corresponding to the same y value. So this certainly is not one-to-one. One-to-one means for 1x, we should only have one y. This is many to one. So in order to have this as a one-to-one function, I need to restrict the domain. Okay, now I have two ways. I'll just erase. I hope that this part is clear with all of you, that this certainly is not one-to-one function at this point, because when we are making horizontal line, the line is touching the graph at more than 1 point. When it is doing at more than 1 point, it's certainly not a one-to-one function. And same logic is used for inverse functions as well, because the underlying idea about inverse functions is inverse of a function exists if it is a one-to-one function. Okay, that is why we are doing the same thing for inverse of a function and for one-to-one function. Okay, now I have two ways. What I can do is I can just say, okay, I can make this line. And now I can say that if I only have the left side or the right side of the graph, this would be a one-to-one function. Okay, certainly. If I divide this graph into two parts and if I erase the left side or the right side, this is clearly going to be a one-to-one function. Now, how do I know if I need the right side or the left side? Okay, for that, this is what the domain was. X is greater than C. Okay, X is greater than C. So we know that X is greater than C. and we need to have the smallest possible value of c. So this way, it only means I can erase the left side of the graph, and now it would make sense. X has every value greater than c, and we are talking about the smallest possible value of c for which for which this function would be a one-to-one function. Okay, so what do you guys think for now? Now I've just made the necessary part of the graph, or the part of graph that is going to be one-to-one. The domain is very obvious. This part is basically going to be the domain. So this is the value, right? It's 2. And we are going till infinity, or, we are going till the end of the positive x-axis. So this means that x is greater than 2. For f to be a one-to-one function, x has to be greater than 2. Only then it would be a one-to-one function. Okay. Otherwise, if this was not given, if I had this, if I had this type of a thing, that x is less than c, and if the statement was state the largest possible value of c, so in that case I would have considered this part of the graph, because it says x is, if as x has every value that is less than a number. Okay, so less than a number would have meant that we were talking about this domain. So for this case, again, the value would have been 2, but the idea was a bit different, right? So do you guys get this question or not? I can definitely explain it again. You just need to message that, or just tell me directly if I should explain this again or not. Okay, let me just explain this again, and then let's see if you guys were able to understand it or not. Okay. Okay. So the first part of the question was easy. You were just supposed to convert one form to the other one. We were easily able to do that. That part is done. Okay. The next part of the question was that it is given that f is a one-to-one function. So forget about everything. If you're not able to understand the idea behind one-to-one, just think about that horizontal line test. Okay. Let me again just get to that point. Okay. So this was the graph of the original function that is written. And now if I make a horizontal line, I can clearly see that through the horizontal line test, since the graph is cutting the line, or since the line is getting the graph at more than one point, it means that this is not a one-to-one function. Okay, so if your horizontal line is intersecting the graph at more than one point, your graph is not a one-to-one function. Just know that. Okay, so for now this is not a one-to-one function, but if we erase some part of the graph, or if we just make some part of the graph, then it might be a one-to-one function. How? If I erase this part, again I have a horizontal line, but my horizontal line is just cutting the graph at one point. So now certainly it is a one-to-one function. Like this part of the graph is certainly a one-to-one function. But if I just leave this much part of the graph, now certainly again when I will make the horizontal line, it is cutting at more than one point. And I've told you guys, you need to make the horizontal line cleverly. You would be able to see directly if the line would cut the graph at 2 points or not, and if the line is cutting the graph at 2 points at any point or at any part of the function, then it certainly is not one-to-one. Okay, now this black line is cutting the graph at 1 point only, but this red line is cutting the graph at 2 points. Since the red line is cutting the graph at 2 points, this entire function is not one-to-one. Okay, so this means I had to restrict my domain by erasing this part. Okay, so we just erase the other half of the graph, and this is going to be my one-to-one function. Now this is some part of the function f, and this is going to be one-to-one. The question was about finding the smallest possible value of c. And what exactly was c? This is how c was given. we were told that x is less than c. Okay, this was the statement. This is basically your domain, and it basically means that x is less than a number. X is, yes, x is less than a number. Okay, this is what it would mean. And in the question we had this. This is what we had in the question. X was greater than a number. X was greater than a number. Okay, so yes, x was greater than a number. For the x was, is there a number for largest possible value? For now we're talking about the smallest possible value. So x is greater than a number. Okay, so now we know that if this part of the graph is only going to be 1 to 1, then for this scenario, what would be that value? That value is going to be 2. This value is going to be 2, right? 2 is the lowest point of the domain, so x is greater than 2, right? That is why we can say that the smallest possible value of c is 2. Yes, now please tell me if you were able to understand this or not, and if not, then what exactly did you guys not understand? Shayan, Ahmed,
Miss,
Munja, Mutsum, yes.
yes, ma'am, I did understand.
Okay, Ahmed and Mutsum.
Miss, I just have the other example that you gave us. It's when x is less than c, or when c is greater than x. So the value will still be 2, right?
Yes, 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 definitely. The value would still be 2. And I'll tell you, although I'm not that type of a teacher, but I'll tell you one thing. Just look at this thing. It's just a 1-mark question. When it's a 1-mark question, trust me, that thing is going to be right in front of you.
Okay.
Okay? Yes. So that is basically the idea behind this part. All right. And Ahmed, are you okay with this question? Any confusions with this one now?
No, ma'am. It's clear.
Okay. All right. Yeah, please keep your mic muted. Yes. Yeah, can you hear me? Okay. All right. So let's talk about the next question now, and then things would make more sense. And please keep your mics muted unless you have a question, okay?
Miss,
Yes.
what if the question asks that tell us about the greatest possible value?
Okay, yes. For this scenario, 1 second. I've scrolled up, but the screen is loading. Yes, can you see this? Can you see my screen?
Hello?
Yes. Okay. Now, so
Miss, what if Miss, were you able to hear me?
yes, now I can hear you.
Okay, Miss, so what if the question was tell us the greatest possible value of C?
Okay, for this scenario, right? For this part, like for this exact question.
Yes.
Okay. All right. For this exact question, if the examiner had asked that you need to find the greatest possible value of C, we are not sure about it for this scenario, okay? If this is the drawing and if this was the domain for this one only, because you can clearly see we are starting from here and we are going till positive infinity and the last value is going to be infinity. We are never sure about what number exactly is going to be infinity, right? But this question can be asked for a different scenario And that was the scenario I just discussed. This question would be when X was less than C, and now the examiner can say, state the largest possible value of C. Okay. Now, students, if you remember, in the beginning, when we started discussing this question, first thing was I made the entire graph. This is just some part of the graph. Let me just again make the entire graph. So this is the function. The vertex or the turning point is going to be at 2n minus 1. This is what we have just discussed. This is going to be the graph. And now this graph is certainly not one-to-one, because again, when I will make a horizontal line, we know that the horizontal line is cutting the graph at 2 points. So it's not one-to-one. So I need to erase one side of the graph. Okay, this is what exactly we have discussed for the smallest value. Again, I can make two parts of the graph. Now, either I can have this part or I can have the other one. Like either I can have the left side or I can have the right side. If I erase either of two, I would again get a one-to-one function, right? Can anyone confirm if my screen is lagging or not?
Miss, your voice is lagging for me.
Yes, I think so. That could be a case. 1 second only. 1 second. Yes, now I know the reason. Just give me 1 second. I'm connecting again. 1 second only. Yes. Is it better now?
Yes, miss.
Okay, perfect. Okay. So again, we had a function. We made the graph. That graph is not one-to-one because of the horizontal line test. The question this time is that your domain says that X is less than C. So X is less than a number, and now it says state the largest possible value of C. So for this part, I am going to erase the right side now. Okay. When I will erase the right side now, then I would be able to have a maximum. Let me just do that. I am going to erase the right side now. I've done that. And now I can see if I look at the domain, it's starting from 2 and it's going till negative infinity. So now the maximum value is possible. Now the maximum value is clear. The maximum value is going to be 2 now. So this time around, we can certainly find out the largest possible value of C or the maximum possible value of C because the situation was different. But if this was the situation, and if you were asked about the smallest possible value of C, you are not sure about it. So the examiner would ask such things accordingly. Okay. But again, just know
Okay.
whenever the question is about the largest and smallest value of X and the function, we will be talking about the next part where it would be about the function. Just focus on this point and on this point, that is it. Whenever the question is about the largest and smallest value of this number, this is going to be your answer. Even if it is largest, even if it is smallest, it is going to be 2 for a quadratic function. It is going to be 2 because it's just a 1-mark question. So you guys can just, keep this thing in your minds for now. Okay.
Okay.
All right. Okay. Let's talk about the next part, next question, basically. And in the next question, it's a bit different. Now it says the function f is defined by f of x equals minus 2x squared plus 12x minus 3. Express minus 2x squared plus 12x minus 3 in the form where a and b are constants. Again, this form is making everything clear that we are talking about the completing square method, but this time around it's a bit different. How is it different? It's different because we have minus 2 here, right? We have minus 2 here. So what do we do for such cases? We need to take minus 2 common. Since we need to have positive x squared, we need to have the coefficient of x squared as a positive number. So I will be taking everything common. So everything includes -2. I'll take -2 common and I would be left with x squared minus 6x and positive 3/2. Okay. So I've taken -2 common and it would give me x squared minus 6x and then plus 3/2. Next, I need to apply the completing square method. So -2 would come as it is. X squared minus 6 would come as it is. Positive 3/2 would come as it is. I need to add and subtract square of a number, and that number is half of this. So it's 6. I'll be adding 3 squared. I'll be subtracting 3 squared. And now I'll just use square brackets here because we have already, used the curly brackets inside. All right. So it's -2. Now I can just use this part to complete the square. I can write it as x minus 3 squared minus 9 plus 3/2. And now I can write it as -2. Again, it's outside. X minus 3 whole squared minus 9 plus 3/2. So -9 plus 1.5 would give you minus 7.5. So I can write it as minus 15/2. And now I can multiply -2. So -2 into x minus 3 squared plus 15. This is going to be the answer. Okay, so this was the initial quadratic expression or the quadratic function, and I've converted it to this form very, very easily. Okay, this was the first part of the question. Let's talk about the second part of the question. Now it says, state the greatest value of the function. All right. Now you need to state the greatest value of the function. Let me just write down the function again. It's f of x equals -2 common x minus 3 whole squared plus 15. Let me just double check. Yes, that is right. Okay. Okay, so again, the question is of similar type. You need to find the greatest value, but not of c. The value is not related to the domain. This time around, the value is related to the function. Again, it's a 1-mark question. The idea is same. The answer is written right in front of you, but still to understand things well, we are just going to make a rough sketch and then the answer would be directly in front of you. Again, this is a quadratic function, and this time around the coefficient of x squared would be negative. So I am going to get a U-shaped curve? No. We will be getting this one because we know that the coefficient of x squared would be negative this time. Okay. So this part is clear. Next thing is about the coordinates of the vertex. So can anyone tell me the coordinates of the vertex for this one?
315.
Very good. Again, this number, negative part of this number, it's -3. So it would be 3 and 15 would come as it is. So the vertex would be +3 and 15. So let's say this is 3. This is 15. This is going to be the point and it's going to be something of this type. This is f of x and this is x. Okay. This axis could be for y, it could be for f of x. It's completely your choice. The question says state the greatest value of the function. So it's obvious the greatest value of the function would come by looking at the y-axis or the function axis. So what do you see? The maximum value of the function is 15. And if we talk about the minimum value, the graph would be going on like this continuously. So we are not sure about the minimum value. Okay. So again, this question would be asked according to the graph. Since the coefficient of x squared was negative here, that is why the examiner has asked greatest value. If let's say if we had +2, situation would have been other way around. Now you guys know if it would have been +2. And then if I will make the graph, So again, the vertex is going to be same. That's not changing, but it would be something of this type. Now you're not sure about the greatest possible value. So for such scenarios, the examiner would have asked, state the smallest value. Okay. So this is how the statement is going to change according to the question. For now, this was the question. We have made the graph and he wants you to find out the greatest value of the function. That was obvious from here as well. But just for the sake of discussion, just for the sake of completeness, we made a rough sketch, a very, very rough sketch. And after making the rough sketch, you can clearly see that the maximum point is 15. And if we talk about the minimum point, it's going till negative infinity and we are not sure about it. Okay. So any difficulties with the second part of the question?
Miss,
Yes.
Miss, in the marking key, it is written f of x is less than or equal to 15. And they say that do not accept the answer if it is only 3 and 15.
Yes, because I'll tell you, because 3 and 15 are basically the coordinates of vertex. And you know why students are writing down 3 and 15? Because just like me, this is how the students are taught. If it's a 1 mark question, you're not going to waste your time in thinking about too much stuff. So they know that, you know, the answer would be coming from one of these two numbers. That is why they're writing down 3 and 15. Okay. But since the question is only about the greatest value of the function, so you can certainly write it down this way, that f of x is one second, it's less than or equal to, and now we can clearly see that the maximum point of this one is 15. So it's going to be 15, right? But obviously this wouldn't have made any sense if anyone was writing it this way. And why students are writing it this way? Because they know that, you know, whenever the question is about the smallest or greatest value of function, or, you know, see, the answer would either be this number or this number. So that is why the examiner would not accept it. Okay. But if the question is about you know, finding out the greatest value of the function only, so you can just, you know, state the greatest value, or you can just write it down this way. But even if you're stating the greatest value of the function, that would also be correct. Like if you're writing 15 is the greatest value, that's also fine, and this is also fine. Both are meaning the same thing, right? So both of them would be considered true. But yes, this would not be true, because here we just know this is the vertex. You need to elaborate further to, you know, make the examiner know that you know the underlying concept, right?
Miss, what if I write f of x is equal to 15? So it's correct, right?
No. If you will write down f of x is equal to 15, then that means like f of x is 15. No, that is not right. F of x is not 15. F of x is 15. F of x is 14. It's 13. It's negative infinity. All these values are correct. F of x is not 15. You can just write it down in English that the greatest value of the function x is 15. That is what I meant, or this thing in mathematics. Okay, this part. Because f of x is 15 just means that, or you can write it down this way, that the greatest value of f of x equals 15. Yes, but if you write it down directly, f of x equals 15, that is not right. Certainly not right, because that just means that f of x is only 15. Okay, so you need to elaborate a bit more. And you know what, the answers in the marking scheme, like when I was in my A2, I had one of the best teachers for chemistry, I still remember. And he told me that the marking schemes are something that are made for the teachers who would be, you know, checking the exam. Obviously, if your answer makes sense and if it is not there in the marking scheme, does not mean that you would not get a mark for it. Okay, it's very obvious that if you're writing it down this way, that the greatest value of the function is 15, that is also going to be correct. Certainly correct. So don't worry about it. And obviously,
Okay.
once we are done with the syllabus, we will be referring to the model answers. We don't consider marking schemes here. We'll be referring to the model answers. That's, you know, what students usually prefer if they are aiming for distinction or A star. We just, you know, focus on the model answers. So we will be talking about those rather than, because marking schemes are made for the teachers, and model answers basically those which are made by the examiner, like the examiner directly, he just considers those answers to be perfect. other answers are also perfect, but there's a way of writing down things and stuff like that. So we'll come to that part later on. But for now, this is equally correct. Okay. Yes. Any other thing? Yes. Any other question?
No, miss.
All right. Munja, Motasam, and Ahmed, do you guys have any other question?
No, ma'am.
No, ma'am.
Thank
No,
you.
miss.
All right. Okay. Perfect. So no other questions. All right. So then that is it for today. I'll be stopping the recording.